Welcome to Crowdfunding with Cryptocurrency. This will be our final demo showcasing our working prototype. Before we get into recent accomplishments, let's briefly touch back on our original idea and progress up to the midterm so we're all on the same page. Next, we'll go over our progress since the midterm, which includes our fully functional trickle system with Bitcoin transaction integration, web APIs for cross-platform functionality, database changes, new services, and additional features. If you recall, our original project set out to create an alternative platform to GoFundMe and Kickstarter. These companies take upwards of 5 to 10% of a startup company's total donations, while also taking up to 3% of each donation combined with a 20 to 30 cent credit card processing fee. We sought out to remove the processing fees and lower the donation fees down to 1%. By using our interval-based trickle system, we're effectively giving the backer more control of their money. We also sought to give startup companies more control over the progress they can display with a feature posting milestone achievements, which are small slices of their project. These milestones have been entwined in two of our trickle systems, which will automatically donate money based on the fulfillment of milestones. We also sought out to use blockchain for its enhanced security, so we set out to use Bitcoin and all the libraries we could get our hands on to write out a transaction system. Moving into the midterm, we accomplished the implementation of a strict layered architecture which promoted code reuse. We have a layer for business logic, followed by a service layer that makes calls to repositories or helper components. We completed our standard trickle system and designed a relational database so that our backend ORM can map the models to tables effectively. Moreover, we completed the bulk of our milestone system, which we touched on earlier. We had also began to spend much of our time on Bitcoin and blockchain research, while simultaneously developing a small UI simply for testing purposes. Let's look at where we've come since then. We'll be touching on each of these accomplishments individually, but first let's look at an overview. We have now completed our percentage-based trickle system and refactored the milestone system to include several security checks. We converted our SQL Server database to MySQL and hosted the database on Amazon Web Services. Possibly our biggest accomplishment is the completion of a fully functional Bitcoin transaction system, which is utilized by all three trickle services. Originally, we were working on a back-end admin user interface, but we decided to take a different approach by writing RESTful web APIs to promote cross-platform integration. Along with these major changes, we've had to add a plethora of helper services and components with respect to our layered architecture. Lastly, we have some sanity checks in the form of basic unit tests to ensure at least some degree of code coverage. Let's go over each of these accomplishments individually and talk about the details. Our first change was refactoring the milestone system. If you recall, the system is based on donations per milestone accomplished. Each milestone is a small portion of the product, such as a video game level or a small feature in a software application. Upon completion, we needed a way to ensure that once a milestone is completed, that milestone will be fulfilled and then ignored by future donations. We already had an email system in place, which was demoed in the midterm. This system simply sends out an email of completion once a startup company sets their milestone to completed. Likewise, if a milestone misses its promise date, a failure email will be sent notifying backers that the startup company failed to meet this milestone. We altered the database to include two new fields, one field that can be accessed by the startup company to set their milestone to completed, and another field that is automatically handled by the system to set the milestone to a fulfilled state after donations have been parsed. Now let's get into the new major trickle system that we've added, called percentage trickle. We've reworked the logic in this system to make it less confusing and more user-friendly. Now this system will slowly trickle a user-defined amount of money until they reach a maximum cap. Once the donation numbers hit the cap, trickling will cease until a milestone is completed. Once a milestone is completed, the remainder in the promised amount will be immediately donated. This maximum cap logic has been implemented for all three trickle systems for the security of our users. So let's look at a practical example. I want to donate $50 in total, but I'm only comfortable donating $1 at a time until a milestone is completed. The company has promised a milestone within 30 days, so my money will be donated at a rate of $1 a day, and I'll set my cap to 30. Upon completion, the remainder of the promised amount will then be deposited. This gives incentive to the startup to deliver progress if they want that last $20, and it gives me the chance to back out whenever I want. We'll be taking a look at all three trickle systems during the demo, But for now, let's take a look at the changes made to our database to ensure our logic runs smoothly. Our database is now hosted on Amazon Web Services. We transitioned from SQL Server to MySQL since Amazon offers a free option for hosting. This meant we needed to switch our ORM simply because Entity Framework Core is not compatible with MySQL using .NET Core 4.0 and above. Thankfully, the Pomelo Foundation has their own version of Entity Framework, which required minimal tweaks to integrate. Let's take a look at the finalized database tables. Within the backer table, we now have a field that stores the private key of each respective backer's Bitcoin address. These keys are used to process Bitcoin transactions, so each backer has a unique key. We've also fixed a bug to ensure that the total money field is always in sync with the total money field of each respective fund account. Our logic works under the assumption that backers have deposited money into a master wallet. This helps with testability, but there's also the option that each backer can have their own unique Bitcoin private key. For the purposes of testing, each backer has the same key in our database currently, since it takes time on testnet to request enough coins. Inside the fund account table, we now have a field called trickle cap, which represents the maximum amount of money that a user wishes to trickle. Once that cap has been hit, no more donations will flow unless the user has chosen percentage trickle and has money set to his remainder field. There's also a bool called has capped, which makes checking caps a bit easier and helps us with performance. Within the milestone class, we now have a fulfilled field, which represents the completion of a milestone. The startup company will set this field to be completed, and upon the next trickle instance, which occurs daily, the system will send out completion emails and donations from milestone and percentage services. Once the donations have been completed, the fulfilled completed field will be set to true, and future trickling will ignore this milestone. Remember, we only want to trickle once per milestone. With this extra check in place, it would have been possible for daily milestone trickling to occur on the same milestone. So this is part of the refactoring that took place. The startup table now has a field called BTC address, which will hold the freshly generated Bitcoin address of each startup company. This address will be used by the transaction system to send coins. Lastly, the deposit class remains unchanged and simply acts as a receipt for each transaction. So speaking of transactions, let's dive into the Bitcoin transaction system. We'll go through most of the code during the demo, but for now let's talk about some of the libraries and components we used. The in-Bitcoin library was used extensively to allow us to create variables for our Bitcoin network and Bitcoin secret, which is based off of our private key. We then used the library to generate a public key, and from there we generate a Bitcoin address. This library gave us pretty much all the tools to create transactions, both inputs and output transactions. So all the logic is very readable and even gave us options for setting miner fees and broadcasting the transaction to our respective network, which in this case is testnet. In order to create a new transaction, we need transaction information associated with a given Bitcoin address. To get this info, we used the BlockCypher web API to get transaction references. Once we get the relevant transaction data, we used the QBitNinja API to get the number of Bitcoins inside this address that are spendable. Again, we'll go into more detail during the demo where you'll be able to see the code itself and watch transactions appear on testnet after the program is run. An additional component that helped us was the addition of a currency converter. This small method uses a free web API that takes in a currency and a decimal to represent a total. The web API then returns that decimal in Bitcoin. This allows us to convert any currency into Bitcoin on the fly, which is incredibly useful considering Bitcoin's value changes daily. So if you recall, the currency stored in the database represents US dollars, so we'll be able to take the backer's money and trickle it based on the absolute current value of Bitcoin per trickle donation daily. We've gone over the various libraries used. Now let's go over the steps involved in processing a Bitcoin transaction so you can see how each library is useful. First, we'll set the network we're using to the Bitcoin testnet. Next, we'll create a variable that holds the private key to take Bitcoins from. We then create a public key from the private key and generate an address. We'll use the BlockCypher web API to get potential transaction information from the related address, which will then give us access to the Bitcoins in that address since we're using the private key. Now, a word on miner fees. Due to the way blockchain functions, Miners are responsible for compiling transactions into blocks and adding them to the chain. In order to incentivize miners to include our transactions, there's a concept called a miner fee. This fee is based on the bytes in the related block, and the chances of our transaction showing up faster on the network depends solely on the fee. Our miner fee is relatively generous, but comes nowhere near the amount taken by Kickstarter or GoFundMe per donation. So back to the algorithm, we have two types of transactions, inputs and outputs. We send coins via outputs to a respective Bitcoin address. Next, we'll send the unspent coins back to our own address. You can think of this like buying a $1 beverage at a gas station and handing the cashier your wallet. So the cashier takes out $1 and then hands you your wallet back. Now, this may seem a bit strange, but it's the reason why we have input and output transactions for blockchain. Lastly, we'll broadcast our transaction to testnet and let a miner include the transaction in the next block. This is generally instantaneous, and you'll see in the demo how we can search BlockCypher to show both transaction data and address data. This will be necessary during the demo to confirm that our transaction did in fact take place. Similarly, we'll confirm that our transaction took place within our own database with respect to the logic in each trickle system. Another big accomplishment in our project has been the transition away from a user interface and toward RESTful web APIs capable of delivering JSON serialized data to a plethora of platforms. These APIs can be called from websites, mobile apps, desktop apps, or just called in a browser for testing, or called by a third party. Our thought process is that most companies who may use this system would probably have their own user interface or application, so we sought to help them out with the use of APIs they can call. Our primary focus has been on the logic required to properly trickle money, accurately storing those transactions in our database, and developing our Bitcoin transaction system. So let's take a look at the prototype. There's a lot to go over and a lot to test. So we'll first have a look at the code itself, starting with the trickle systems and the inner components. Next, we'll go through the logic in the Bitcoin transaction system, and to get a firm understanding of how our system works, we'll take a look at the database and the current values for our Bitcoin keys. The demo itself will consist of showing all three trickle systems engaging in one day of trickling, which includes a Bitcoin transaction per fund account. We'll also look at the newly refactored milestone system and the brand new percentage system. We can then manually set a milestone to be completed and confirm that the remainder of the promised funds are deposited both in the database and also on the blockchain. We can also locate the respective milestone in the database and confirm that fulfillment has been completed. Bitcoin transactions will be confirmed via BlockCypher through the use of searching the transaction and the address. We can also verify these amounts by searching the private key and individual addresses of each starter or backup. Lastly, we can confirm that trickling does in fact stop once a cap has been hit. Alright, welcome to the demo. So I'm going to try and take this step by step so we're all on the same page here. For starting, we have the startup class right here with its new field BTC address, and if you look in the database here, we can just do a little search for all the startups, and you'll see down here, here's the field that gets mapped. Each one has a unique Bitcoin address, and if we go over to the backers, then you'll see each one has their own Bitcoin private key, which is also mapped in the database right here. Now, as I mentioned before, we have currently a hard-coded Bitcoin private key as a master wallet. This can be changed in the future, but requesting coins on the Bitcoin testnet address, it limits us to about a fraction of a penny, really, every like 8 hours. So using a master wallet is very helpful for testing, and it'll show that everything works fine. So let's go over to fund accounts. You'll see earlier we mentioned the remainder, the total donated, trickle cap, and the has capped, which is a bool. These are new additions. The remainder is specifically used by the percentage trickle system. So if we go over to fund account, you'll see that we have we have one fund account because I want to take this kind of slow. We do have 3 backers and 3 startups. Currently, there's only one fund account, which is a handshake between the backer with the ID 1 and the startup with the ID 1. It is not capped, There is no remainder because we're using the standard trickle system. He's currently donated $48 and the trickle cap is at 50. So we'll be able to see a transaction. I can run it twice and it'll hit the cap, and we'll be able to see that it has capped and no more transactions will go through. So in terms of trickling, we have our daily tasks function right here in the trickle tasks layer, which is our business logic. We have a switch statement that's just going to find the standard, milestone, and percentage field within the fund account. Because if you remember, that's what we're iterating through. So if we have a fund account that is standard, we're just going to call trickle. And for milestone, we're going to call the milestone trickle, percentage system, percentage trickle. All three of these will eventually call the standard trickle method. So let's take a look at what trickle actually does now that it's been refactored a good little bit. We're going to double check and see if the total donated in this fund account is greater than or equal to the trickle cap. If it is, then we have capped, and we're going to update the database accordingly. We're also going to do a check to see if the total money in that fund account is greater than or equal to the trickle amount, and we're going to check and see if has capped is false. If that's true, then we know there's enough money in the fund account so there's no overflow, and we know that we haven't capped. So we're going to use our currency converter to basically make a call to this web API with US dollars being the fiat of choice, which is just the currency, and the trickle amount within the fund account. So if we go to the implementation, then you can see it's a very simple web API call, and it's going to return the values that we want, which it'll be pretty low amounts considering that we are basically just donating $1. So just a few satoshis at a time. Okay. So next we're going to make a call to the send transaction function in our transaction BTC layer. And similar with the midterm, we're just going to be updating the database accordingly with the total received, total donated, total money fields. And we're also going to update the backer table just because we want the fund account's total money and the backer's total money to cascade with an update. And that's currently implemented in the database, but this is done just as a double check. Okay, so let's take a look at the Bitcoin actual implementation here. Okay. So the first thing we're going to do is make a variable for the network so we don't have to retype network.testnet. Then we're going to set the Bitcoin secret that we've been using, which again is hard-coded right here. Okay. After that, we're using the block cipher API to get information for the address. So from there, we're going to be getting a list of the transactions, just the TX refs associated with the address, and the number of transactions, which is n_tx, just to help with looping through them. So in the data we get from block cipher, the same transaction ID can be listed multiple times in some cases. So every time we find the same transaction ID, we add 1 to the max transaction so we can actually loop through it all. The loop itself really just checks each transaction to see if it's spent and if it has at least 6 confirmations, which we'll be going over when we actually look at the blockchain over in Chrome over here. So 6 confirmations seems to be commonly used as a minimum. It's more secure the more transactions that you have. You'll see if I scroll down, some of these transactions have 2,000 confirmations. So once we find a spendable transaction, then we take the ID and throw it in to what we had already implemented to send money with the other API, QBitNinja. The main difference is the way that these fees are calculated. The fees are based off a number of bytes and the current recommended fees. If you remember, I mentioned miner fees. So testnet is relatively low, and we're using a recommended amount. So our transactions show up on the chain pretty much immediately. So again, the number of bytes per block is based on the number of input transactions and output transactions, and we have 1 of each. So the parameters are used to make one of the outputs of our transaction, and the amount and who it's going to go to. So as for the transaction inputs and outputs, they just refer to the parts of the transaction, the transaction inputs and outputs of previous transactions that we received. So really we're just using the output transaction of a previous transaction that was sent to us as an input. It can get a little bit confusing, but in this case we're sending coins to the other addresses and sending the rest back to ourselves. If you remember the analogy from the PowerPoint with going to a gas station, spending $1, handing the cashier your wallet, and then it gets handed back to you. So that's just kind of the way that blockchain works. So then we can use the output of the transaction we sent to ourselves as an input in another transaction. So right now, we're only using one input, which is the most recent spendable transaction sent to us that has been confirmed more than 6 times. It's essentially what we have left in our wallet. And lastly, of course, we're just going to be doing some checks to make sure everything's fine and outputting the miner fees. We're going to be outputting the address and also the transaction ID, which we're going to be looking at on BlockCypher here. Okay, so if we go into the database here, as I said before, we have one fund account. I'll be adding the others incrementally. We're just going to take this one step at a time. So we're going to be trickling $1. So let's go ahead and run the application. We're iterating through the list of fund accounts. Currently there's only one. Here's the address of the startup. Here's the transaction ID. Here are the fees, the miner fees. We have 5 confirmations for this. And success. So now we can look at the hash of the transaction in the Explorer. Let's take a look at that transaction in BlockCypher. And this is our current hash of the transaction. This was one from testing less than a minute ago. So here's the fees. They match up right there. The amount transacted. And you can see it's currently 0 of 6 confirmations because it's brand new right now. So again, the details, it's showing us the address and where it's going. Okay, so everything seems to be working perfectly fine right now. Let's go ahead and double check that this actually worked in the database. So now we can see that the total donated is 49. And we're about to hit that trickle cap. So why don't we run the application one more time. Success. We already know that the transaction has gone through. And now we can look back in the database. We have now hit the trickle cap. So now, if I run it one more time, then hasCapped should be set to true. This total money should not hit 387. And there should not be a transaction. There is no transaction. Everything closed. So let's take a look at our fund account. hasCapped has now been set to true. So using this logic, the user can feel kind of, at ease. So next, I'm going to show you the percentage trickle system. All right. After using a Bitcoin test faucet to give me a few more, test coins in one of my startup's wallets, we're now ready to show the percentage trickle system. So in fund accounts in the database, you can see I've added a new fund account. Trickle type is percentage. Trickle cap is going to be set to 2. Trickle amount is set to 1. Total donated is 0. The remainder is going to be 1. And hasCapped is 0. Now this is related to the the startup with an ID of 3. So if you remember from the percentage trickle system, we are going to trickle daily up to a cap. And whether or not a milestone has been accomplished is what's going to determine whether or not the remainder gets added to the total money given to the startup. So if we go into milestones, you'll see down here at the bottom, there's one that's related to a startup ID of 3. Now fulfilled is set to 0 because I want to show you the actual trickling first, and then we're going to go into the database, set this to 1, and then eventually fulfillment will be completed. And where it says trickle cap, total donated is going to be 3. Now that doesn't mean that we've gone over the cap. It means that we may have hit the cap, but we have the remainder to still donate money with as long as a milestone has been completed. Okay, so let's go ahead and run this. We have our fees, transaction ID that we're pulling from, and the success. Let's take a look at this transaction. Okay, received less than a minute ago. No confirmations just yet. Same amount of fees. Our fees are currently a hard-coded recommended amount, so that's pretty much why they get mined pretty quickly. And here's the amount. Okay, now in the database, if we look back at fund accounts, then we see total donated is 1. The remainder is still 1. We have not had a milestone that's been completed yet. Okay, so let's look at milestones real quick, and let's set the fulfillment to be 1. So this milestone, if I run this, okay, this milestone has now been completed. It's a milestone from the startup ID of 3. Let's go back into fund account and let's run the application again. We are going to expect to see one more trickle followed by the remainder going into total donated. So this field is going to need to say 3. And we're also going to cap at that point. Success. Let's take a look. Less than a minute ago. And you can see this isn't the exact same transaction as before. This is a whole new one that we just made. So amount transacted, you can see that this number is a little bit bigger than the one that we originally had, which was just 1. This one looks to be twice as much, and that's because we're donating 2. We're donating 1 for the trickle amount, and then another 1 for the remainder. So if I refresh the database, that should, yep, total donated is 3, remainder 0, and we have now capped. And if we go into the milestones, we can see that the fulfillment has now been completed. So everything is working pretty well. Let's go into the actual algorithm and look at how that's working. So in trickle tasks, we have our switch statement. If the fund account's trickle type is percentage, we're going to call percentage trickle. So we're going to do a couple base checks right here. We're going to make sure that we have not capped, and we're also going to make sure that there's no overflow. So the total donated needs to be less than or equal to the trickle cap minus the trickle amount, just in case the user has some money, but the trickle amount exceeds the amount that he has. And of course, calling our base trickle method and our overloaded milestones, check milestones method, which is going to take in the relevant fund account. We're going to grab a list of the milestones by this startup ID, which in this case was ID of 3. We're going to loop through all the milestones. We're going to check and say, hey, has this milestone been fulfilled? Well, has the fulfillment completed? No? Okay. Then we're going to add the remainder to the total donated, set the remainder to 0, set hascap to true, and then update the database accordingly. Okay. So the last thing that we can do is go in and take a look at the startup whose ID is 3. We'll take a look at their address right now. So here's how much Bitcoin they've received. There's their balance. We can see 0 of 6 confirmations because we just had a transaction. If you recall the numbers in that last transaction, it was twice as much as the one before that, which I believe was 0.003. 0.003 relates to $1. 0.00653 is $2 minus the miner fees. So yeah, everything's working swimmingly. We have the other transaction that we did before showing the milestones. It's already got 1 confirmation. And typically, we want 6 confirmations before we use one of these transactions as an input for any other transactions in the future. So down here, you can see there's been a pretty good amount of testing done. And yeah, I think that covers the percentage system. And since this video has already gone over probably 30 minutes, I've already shown the milestone system in the midterm, and we've also gone over the milestone integration with the percentage system. So I think that sums everything up. Lastly, we're going to have Dan take a look at the web APIs that we have written. And I can go ahead and show you those in terms of code. He'll be able to show you them in action. So we're going to have some web APIs here to get all backers, get all milestones, get all startups, get all the fund accounts, get a backer by a funder ID, get fund accounts by a backer's ID, get milestones by a startup ID. And many more of these could be written in theory. I mean, in our trick, all these are doing are calling service layer methods that interact with the database through Pomelo's Entity Framework Core revision. So really, it's really open for changeability, modifiability. The amount of code reuse is pretty splendid in this, considering we've layered everything pretty well. So that's going to conclude everything for me.